Hello, my name is Sofia Alonso,
And I'm Meaghan Desilets.
and today we will be talking about the ideal gas law. The first thing that we're going to be discussing is what exactly is an ideal gas. So there are three assumptions that define a hypothetical ideal gas. And the first one is that the interaction forces between the molecules is negligible. This means that all the collisions that occur between the molecules are elastic. The second assumption is that the volume between the molecules is also negligible. And the third assumption is that the molecules are all moving at random motion. Of course, we know that in a real gas, these assumptions don't hold to be true, since the molecules do occupy some volume, and since there are some interactions between these molecules. However, these assumptions help us simplify the predictions of the behavior of these gases, and they allow us to complete calculations using the ideal gas law, which is stated here. The ideal gas law is PV equals nRT, where P is absolute pressure, V is volume, N is the number of moles, R is the ideal gas constant, and T is the absolute temperature of the gas being analyzed. So the ideal gas law describes the relationship between all of these properties.
So there are some situations where the ideal gas law is a reasonable assumption and some where it isn't. The ideal condition for a gas is standard temperature and pressure, where temperature is defined as 0 degrees Celsius or 273 Kelvin, and pressure is defined as 1 atmosphere. So these characteristics can deviate from STP, but they have to deviate in specific ways. So for temperature, if it gets higher than standard temperature, that doesn't affect the interactions between the molecules or the forces. They're still negligible, and you can still use the ideal gas law. It's okay if it gets a little bit lower than standard temperature, but if it gets much lower, then this creates more and more interactions between the molecules and therefore non-negligible forces. For pressure, it's okay if the pressure deviates below standard pressure, but if it deviates too much above standard pressure, the increased pressure causes increased interactions between the molecules and therefore also non-negligible forces. And in either of those cases, the ideal gas law cannot be used.
So now we're going to be seeing some examples of when the ideal gas law is or isn't a reasonable assumption. In this first problem, we're going to be showing why it is a reasonable assumption. So here we have a person breathing at sea level. We have an inspired gas stream, an expired gas stream, and a stream of gases being transported from the bloodstream to the lungs. So in this problem, we know the composition of the inspired gases, the composition of the expired gases, and the temperature of these two gases as well. We also know the volumetric flow rate of the inspired gas stream, and we know the pressure. Since this person is at sea level, the pressure would be assumed to be at 1 atm. What we're looking for is the mass composition of the stream of air being transported from the bloodstream to the lungs. And we're trying to find this by ignoring any reactions that might be occurring. So in this problem, the first thing that we want to do is find the number of moles in the inspired stream. And we would be able to do this by using the ideal gas law, which is PV equals nRT. The reason that we would be able to assume that the ideal gas law is reasonable is because the pressure is at STP and the temperature is so near that at the temperature of STP that the ideal gas law is still a reasonable assumption. Since we have the pressure of the inspired stream, the volume of the inspired stream, and the temperature of the inspired stream, we're able to find the number of moles using the ideal gas law, so we can ultimately find the mass composition of the gases being transported from the bloodstream to the lungs.
Okay, and now we'll look at an example problem where the ideal gas law is not a reasonable assumption. So in a typical scuba tank used by a diver, the tank would hold about 11 liters of dry air. So the pressure in the tank is, they come in different pressures, but one available pressure is 2,640 pounds per square inch, and the temperature is usually just around 30 degrees Celsius. So in this problem, we're asked to find the number of moles of air in the tank. So in this problem, the temperature that we're given is very close to standard temperature and it's above it, so we know that that is okay for using the ideal gas law. However, the pressure that we're given is quite high. It's much higher than the standard pressure in PSI, which is 14.7. So therefore, this does prohibit us from using the ideal gas law because the intermolecular interaction forces would not be negligible inside the tank. If we did, however, want to find the number of moles in the tank, we could do that using the real gas law, which is listed here. But to complete this equation, we need the van der Waals constants for the compounds contained in the tank, such as, in this case, oxygen, nitrogen, and carbon dioxide, etc. And these are not given to us in the problem, and we're not really going to worry about that or get into it today. But that's what you would do if you wanted to complete the problem.
So that concludes our video. We hope that this was helpful, and thank you for watching.
Thank you.